here at DAC 2018, and here at Aldec booth I'm demonstrating how you can use UVM test environment to test C designs. Pretty much we are using UVM Connect to do that, and in this demonstration I will be talking to you about various roadblocks that are currently stopping you from doing it, and what are the benefits of using such an environment where you can use existing UVM environments to also test your C designs. So let's take a look at that. Here we will be talking about the benefits of high-level synthesis tools and what they offer you. And as you all know, high-level synthesis tools allow you to raise the level of abstraction. They make it very easy to create new code, and also the ability to use advanced verification methodologies along with this high-level synthesis RTL is very useful if you want to quickly generate code and generate test environments. And in this presentation we will be seeing exactly that, how to use UVM and UVM Connect to connect with a C-based RTL or a C-based DUT. So the current limitations in any HLS tool is that you cannot really use your C model and the RTL model and use the same test bench to check that. And C code testing is done separately, and you do some kind of co-simulation with the RTL, but always the results are compared separately. And you cannot reuse the test environment, so that's another drawback. And the current Accelera UVM System C is still in beta, so we're not really able to use that. And also you can see the verification capabilities of HLS tools are not very robust in terms of the features they provide. And in an ideal scenario, you would want to reuse your UVM test environment to make sure your C design is working correctly even before you attempt to run any kind of high-level synthesis. And you want to move everything to a higher level of abstraction, so you can also use readily available simulation tools to simulate and debug. And UVM Connect makes it vendor independent as well. Some of the considerations for this demo is that you have some knowledge of how UVM System C and UVM Connect works. And since there's no standards to guide this process, we are kind of using what's available to us. And we are trying to reuse as much as pre-existing methodologies as possible. So here's the solution. In this particular demo, we will be comparing Verilog DUT results with the C model results. We are sending in the same stimulus to both models and getting the results back out, and then checking them again in the UVM environment to make sure they are both the same. And this is how the UVM environment looks inside of using Riviera-PRO's UVM graph. So let's jump into the demo and see how this looks in Riviera-PRO. And in this demo, we will be taking a look at a design we created. It's a simple, very simple design which calculates the square root of an input incoming value. The design was synthesized using, the high-level synthesis has been done using the Xilinx high-level synthesis tool. And the generated RTL is compared against a regular C model C function for finding a square root. So let's take a look, and we can quickly run this demo right now. And while this is running, let's talk a little bit about the various things that we had to do. Is that on the C side and on the UVM side, we use UVM Connect to do the connections between C and UVM, and we use the UVM Connect library to achieve that, and that is based off of DPI library that is used in SystemVerilog. And in this, so the example has finished running. So as you can see, we are comparing the reference model or the C model output with your output from your DUT and see if there are matching. And if they indeed are matching, you can see that there is a match that is being generated from your UVM scoreboard right here. And all these connections are done using TLM connections between C and SystemVerilog. In this particular example, we are using TLM1 connections, but you can also use TLM2 connections if you want to do that. And in this particular example, we can generate the UVM graph to take a look at how this environment looks inside of UVM. And as you can see, we are using a UVM environment where we are trying to drive the Verilog RTL, and we are trying to use the same input and using a FIFO, TLM FIFO to store those transactions, and then those transactions are read by the C code, and the output is generated again by the C code and also the RTL, and those both those outputs are compared in the UVM scoreboard. So in this particular demo, we are seeing that both the RTL and C code results are matching, and we do that using UVM Connect in System C, and using that we are trying to show you how we can reuse a UVM environment for System C or even a C model. So that's all for you guys, and hope you guys are having a great day.